It's June 29, 2021. And here's a Hamfest special I picked up. Needed some work done. I got it working. And this particular one, this is a Hewlett-Packard 1707B. It's not a real fast scope. It's 75 megahertz, but it's very well built. It's not a Tektronix, of course. But anyway, this one came with a battery option, which came in this case here. And it was packed with nicad batteries. Very old. A lot of these were leaking. I took them all out and cleaned them up. And anyway, this battery box here, I plan on rebuilding it with lithium batteries, lithium-ion batteries. I won't have any trouble fitting them in here because they're a lot smaller. I'm going to use 18650 batteries. Anyway, this battery box here will fit inside here, and then it plugs into this connector here. And when the scope is off but plugged in, it has a charging rate, at least with the nicads, of 400 milliamps. So what I plan on doing is using 18650 batteries. These are batteries that have been salvaged out of old laptops, and I've tested them all, charged them. I've graded them according to their capacity, so I'm going to get the main ones I can get that are in the best shape, and I'm going to use 6 of them in series, and then each series unit will be made up of 4 individual cells, so 4 in parallel, and then 6 of those in series. And then I'll use one of these battery protection circuit boards, which I got from, I think it's AliExpress. And basically how this works, here's a schematic of it. You can connect 6 18650 cells in series. That's what I plan on doing, although I am going to parallel cells to get a higher capacity. This thing uses, the scope uses a little over 2 amps when it's running, 2 to 3 amps, so that shouldn't be a problem. Now when the scope is off and it's in the AC position, this connector here has 30-some volts in it, which may be a little high, so I'll have to experiment with it. I'm not sure if this board is going to like 33 volts. It should. I think it should work okay. If not, these things are really cheap. So anyway, I'm going to build a battery pack with old lithium-ion cells, and then when I'm done, this battery pack will be placed inside of the scope here. So that's the plan anyway. So I'm going to build a battery pack and then do some testing, and let's see how it goes. Well, here's the completed battery pack. This is half of the shell. The other half will go on top of here. And as you can see here, 23.63 volts. So it's not very pretty, but it should work. Next step will be to connect the battery protection circuit, which is this. And that'll go across each of the series parallel lines, and then that will protect it as it's charging and discharging. It's got some protection built in for short circuits or overcharging. If each cell charges up, it'll cut off at let's see, I think it cuts off at like 4.2 volts, something like that. So next step is to connect the protection circuit. Here's the completed battery pack. On top I've got the protection board wired up across the cells, which are, here's a schematic of how it should be done. Of course I have 4 cells in parallel for each series string here. Anyway, I've got it charging. Here I'm simulating the charger from the oscilloscope, which will charge at about 400 mils. I got it set right about 30 volts, so it's in constant current mode right now. So I'll let it charge up. Right now the pack is at 23.9. So once I charge this, then I'm going to put a load on it and see how well it runs. Shouldn't have any problems. With 4 cells in parallel, and then each of those, 6 of those in series, I shouldn't have any trouble here. So the next step after this will be to package this, put it back in the scope, and see if it works. See if we get any smoke. Okay, the scope is running on batteries now, and after 30 minutes the battery pack is still at about 22.9 volts. I haven't packaged it yet in the original enclosure, but the scope's working alright. Now when I turn off the scope and have it plugged into the AC power with a switch off, it'll charge this battery pack at about 400 mils. Well, this has been running for over 3 hours and 8 minutes on the battery, and the voltage is still holding 21.2 volts. And this thing will run down below 20 volts, so I think this is going to work. Over 3 hours of battery time is more than I'll ever need. So let's see how we're doing here. Here's the data as far as times go. So I'm going to put this pack back together. It's going to go in these 2 clamshell cases, and then it'll go back into the scope. And then when it's plugged into AC, it will charge itself at about 400 milliamps when the scope is turned off, and when it's on, it'll trickle charge at about 40 milliamps. And that may change. I'm going to do some more tests. That's with the old nicads in it. So we'll see what happens with the lithium batteries. And these were all salvaged from laptop computer batteries. And I just graded them and I matched them up as best I could. And here's a side note on the original nicads that were in this scope's battery pack. I took 10 of the best cells that weren't leaking and I combined them to make a 12 volt battery pack. Charged it up, and I've got it on a load test now, running at 2 amp load, and I'm going to stop discharging at 10 volts. This test has been going on for an hour now. You can see by the stopwatch. And the voltage is still over 12 volts. So these batteries, considering how old they are, that's pretty good capacity. And I'm going to run these down to 10 volts, charge them up, and do it again. And I'm assuming they're going to recover even better after that initial discharge cycle. So I don't know what brand of batteries these old nicads are, but they were pretty good. This scope goes back quite a few years, and I was really surprised. A lot of them were leaking quite badly, but these were the best of the worst, if you want to say. Anyway, I'll use this battery pack. I'm going to mount it in some type of a box, put some terminals and a small digital panel meter on it so I can use it for experiments where I don't have a line operated power supply. Here's the completed battery pack. It will be installed in the scope in this area right here. Unfortunately, I can't use the studs that went through the pack because of the arrangement of the lithium cells. When I had the vertically mounted nicads, there was space for these screws to go through. So what I'm going to do, run strips of Velcro, and this will be Velcroed in, and then the connector here will meet with this connector. Here's the battery installed. So the next step is to put the cover on, and then this project will be done. And we've got a heck of a thunderstorm going on out there. Here's the unit back together, running off of the battery. Using this battery pack, I get about 3.5 hours of charge on it. The battery protection circuit I'm using cuts off the load at about 21 volts. So that's about 3.5 volts per cell average. And then it'll cut off the charge at 24.5 volts. It charges when plugged in on AC with the switch off. It charges about 300 milliamps with this particular arrangement. So, you know, plug it in, leave it on 12-15 hours. It's up to full charge. 3.5 hours is enough to run on a charge for anything I'd need. And let's see what else. Once again, I used 24 cells. These were salvaged from old laptop batteries, and I graded them so they were matched as close as I could get them. And there were 6 series connected 4-cell banks. And once again, I used this 6-cell battery protection circuit from China. Worked pretty good though, I must admit. So I guess I'll wrap this one up, and got a few more little things I have to do on the scope. I noticed I'm going to have to go into the circuitry a little bit, but it's running pretty good. Anyway, that's it for this one. Thank you for watching. Bye.